Do you have plants that grow lopsided? Does everything you touch die? Are you tired of being the laughingstock of the homeowners association? Well, then this product is definitely for you. The solar motion tracking device for outdoor potted plants is what you need to tackle all your gardening failures. Just simply open the clear door and tap start on the LCD screen. Put in your latitude, longitude, and time zone with the USB keyboard. Next, add your beautiful 6-inch diameter pot of 5-pound vegetation to the planter conveniently located on the top of the device. And then you're all set. It's that easy. The device will tilt the plant based on the sun's location all throughout the day, so you can sit inside and do nothing. It even works all year round, but just remember that not all plants grow in the fall and winter. Feel free to water your plants a healthy amount per day without straining to turn those bad boys. You don't even need to worry about excess water. Why? Because our gutter system spits that out in a jiffy. The entire system is waterproof, so it'll do its job rain or shine, much like you. So what are you waiting for? Do you want a cool new system to spice up your garden and have jealous neighbors? Do you want to make sure no moles eat through your hydrangeas? Do you want to be successful in your life? Then buy our exclusive, state-of-the-art solar motion tracking device.
The system was initially designed in Fusion 360, where assembly features such as fixed and rotational joints were used to test the range of motion of the mechanism before the prototype was built. Stress analysis was also conducted in Fusion 360 to ensure that the components we selected would not break in operation. We performed a stress analysis on the entire structure by applying a 5-pound weight to the top tilting platform at the most extreme angles of motion. We also performed stress analysis on the individual components that would be subject to gravity and the weight applied to them by the rest of the device.
Our project is based on using a 3 degree of freedom Stewart platform to provide the dual axes required. The inner workings include link length calculations using robotics knowledge. The two platforms correspond to their own coordinate system. Each actuator's top and bottom part have their own coordinates that are represented by their relation to the platform they're on. A transformation matrix is multiplied by the top platform coordinates to relate them to the bottom platform. Based on this image, it's easy to see that the lengths of the actuators are related by vector addition. Therefore, the lengths adjust based on desired rotation.
The inner workings of your new plant pot are simple: a rechargeable battery, 3 relays, a Raspberry Pi, and several fuses in between to ensure that your plant pot is safe and unbreakable. Here you see the battery, the fuse, a terminal to distribute power, and the relay connections to the actuators. The Raspberry Pi holds your system on-off switch and connects to the pins of each relay for easy and safe control. This system comes together in a simple and easy-to-use interface so that you won't have to worry about anything but putting in your location and time. Taking a closer look at our system, we can inspect these individual components. This 12-volt, 12-amp-hour battery is capable of being the single power source for all of the system. The battery runs to a set of solid-state relays, which act as on-off switches for the actuators. These are all simply powered directly from the battery with no voltage converters or adapters. However, taking a look at the Raspberry Pi, it's easy to see that the logic and control portion of the system doesn't have the same hefty voltage and current requirements that the actuators do. Here, a converter is placed in between the fuse from the battery and the on-off switch to the Raspberry Pi. From there, the Raspberry Pi delivers a small voltage to a breadboard so that the logic pins on the relays can receive the right control and move the actuators accordingly. Altogether, these components function so that you can set your plant pot up and then let it run without worry.
The Raspberry Pi is programmed to run the final code on startup, and the user will be greeted by the Graphical User Interface, or GUI. The GUI first welcomes the user with "Welcome to Solar Motion Tracking for Potted Plants," and asks the user to follow the on-screen instructions to input their latitude, longitude, and time zone. A chart of the time zones and the corresponding number to enter will be given to the user. Time parameters are already built into the Raspberry Pi. The system first extends all 3 actuators so that they are at the starting height of 16 inches. The program then checks to see if the time is a whole hour or whole half hour. If the time meets these constraints, the program uses the user's inputs and time parameters in the azimuth elevation function to calculate the current position of the sun. The program then uses the link length function to determine the length required of all 3 linear actuators in order to achieve the angle that will face the plant towards the sun. It then extends or retracts each actuator depending on their previous positions. If the time is not at a whole hour or whole half hour, the program does not move the actuators, and it checks every minute to see if the time meets the criteria. It will then repeat the process of calculating the position of the sun, determining the lengths of the linear actuators, and extending or retracting them at the next 30-minute interval.
The mechanism we use to achieve this steward platform is based on 3 identical linear actuators arranged in an equilateral triangle. The bottom of each actuator is connected by a hinge to the bottom platform. A ball joint then connects the top of the actuators to the top platform at a right angle. This configuration gives the plant the required freedom of motion to create the angles it needs to track the sun. The linear actuators we purchased are rated IP54, which make them suitable for outdoor use. But to provide a further layer of protection, we used rubber sleeves over the actuators to raise it to comply with IP64 standards. The electronics have 2 layers of protection against weather. The first is that the battery and microcontroller are placed inside IP65 and IP67 rated waterproof electronic junction boxes, and the extruding wires are protected with rubber gaskets. The second layer of protection is the base platform. It is made of waterproof materials and the edges are sealed with silicone. We tested our waterproofing measures by leaving the device operating through a night of heavy rain, and it remains safe and dry.
Now we will take a look at normal usage by a customer. First, find out where north is from the compass on your smartphone and have the clear screen facing that way. Ideally, the screen would have arrived and been hooked up to the Pi already, as well as the USB keyboard. In that case, the user would have to open the clear panel like a door, tap Start, and type in the coordinates when the GUI appears. Then they would be done and their device would run. Backups are also used. There are 2 ways to connect to the Raspberry Pi. The first way is to connect the portable keyboard with the USB and the LCD screen in the respective ports on the Pi. Then tap the program in the center of the screen and tap Run at the top. A GUI should show up and just add your coordinates and your time zone. Submit and the device is ready to go. You can then unplug the keyboard and the screen at this point. The second way is to connect to a remote desktop. Do the same procedure with connecting the portable keyboard and the screen, but just connect to your home's Wi-Fi the way you normally would with a computer. This can be done once so everything is set up. Disconnect everything and use your personal computer or laptop. Connect to a remote desktop with a VNC viewer for Mac or search for a remote desktop on your PC. Next, put in the computer credentials shown on the screen and the password, which is password. Hit OK and you should see a program in the center of the screen. Click this again to open it and hit Run to input your coordinates like before. That's it! Your device works from your home instead of you having to go out from now on. And this is a quick demo of your device working with your inputted coordinates and your time zone.